Hello and welcome back. If you are interviewing for a senior DevOps role or SRE or cloud architect role, knowing basics Terraform command simply won't cut it. Hiring managers want to see that you can handle state management complexities, multi-cloud challenges, and advanced module design. Welcome to the ultimate Terraform deep dive. In this session, we are tackling 15 advanced scenario based interview questions designed to test your real world IAC expertise. We are going beyond Terraform init and diving into topics like zero downtime state migrations, custom providers, and managing drift with third party tools. If you can nail these answers, you're not just a Terraform user, you are a Terraform master. But before we start with our first question, please hit that like button and subscribe to the channel. Your support helps me create more in-depth content like this. Let's get started with the single most important concept, the state file. Explain the purpose of the Terraform state file. What are the risks of using local state in a team environment and how do you mitigate them? So we know that state file is what we use in Terraform to keep track of all the resources that Terraform is creating for us. So this state file helps us to map the desired configuration to the actual deployed infrastructure. This state file helps us to keep track of the metadata and the dependencies of the resources. Now, if you're using local state file, this can lead to state corruption and raise conditions from concurrent operations. So how do you mitigate this? Use a remote backend. So the standard practice whenever we are working with Terraform is to use a remote backend like S3 bucket or Azure storage with state locking feature enabled. This ensures that mutual exclusion is applied when you're running a Terraform apply or the Terraform plan command. The next question we have is you accidentally provisioned a sensitive database using the wrong module and the Terraform destroy command is failing due to dependencies. How can you remove the resource from the state file without destroying the actual cloud resource? So for this, we can use the Terraform state rm command. So basically the command would be Terraform state rm, your resource type dot the resource name. For example, let's say you want to remove an instance. So the command would be Terraform state rm aws underscore instance dot the name of the instance that you have given. This command will remove the resource mapping from the state file and this will make the resource unmanaged by Terraform. So basically that resource will no longer be managed by Terraform. The actual cloud resource would still be running in your cloud, like let's say the EC2 instance in AWS, and you must manually destroy that resource later, which will resolve the dependency issue. The next question we have is when should you use a data block versus an input variable to get information into your Terraform configuration? Give a practical example. So input variables are used for configuration inputs that change frequently or are very environment specific. Now with your input variables, the data is supplied by the user. For example, your instance type. So instance type is something that is provided by the user. Now the data sources on the other hand is used when you want to fetch information about your existing resources. Like you already have that resource on AWS and you just want to fetch the information about that, and this resource is not managed by Terraform. So basically your data source is a read only query. So example would be like, let's say you already have the VPC. Now you just want to get the information like the VPC ID of the VPC from AWS. Then we can use this AWS underscore VPC data source to fetch the information about your existing VPC. The next question we have is you need to output the connection string for a newly created Redis database, but you must prevent the password from being displayed on the console or stored visibly in logs. How do you secure this output? So whenever we talk about exposing certain informations, we can make use of the output block. But in this case, since it will be a sensitive information, we can use the sensitive equals to true attribute within your output block definition. So this output value will now be masked because it is a sensitive value and it will not be displayed in the console output or in your CI/CD log. The raw value is still stored in an encrypted state file but protected from accidental exposure during your command execution. The next question we have is what is configuration drift and how do you proactively detect and resolve it in a complex environment? So drift is basically a situation when you have your cloud resources actual state differ from the state defined in your state file. So basically the resources that you have in your AWS and your state file are mismatching. For example, let's say in your console you are using t2.medium, but the state file is having a t2.large. Now that's a drift that has occurred. So you can schedule automated read-only Terraform plan runs like every night, or use specialized tools like Drift CTL or HCP Terraform. So running Terraform apply will revert the manual change back to the desired state defined in the code. All right. So basically, Terraform will go ahead and make the necessary changes when you run the Terraform apply command. But the thumb rule is, if you're using Terraform, never ever make manual changes to your resources like in the console or via CLI. Always make the changes using Terraform code. The next question we have is, you are designing a reusable VPC module for your organization. What are the three most important features you must incorporate for flexibility and maintainability? So the first thing is to use the validation block to enforce constraints on variable inputs, like using the correct CIDR format. Then explicitly define outputs for all the necessary attributes like your VPC ID, the subnets ID that can be later consumed by other modules. And then use this for each or count meta arguments with variables that allows users to dynamically provision resources. Example, specifying the number of subnets that you want to create, or the rules that you want to add, and all those things. The next question we have is, your team needs to migrate a large live applications infrastructure from an old S3 state backend to a new HCP Terraform backend. How do you perform this migration with zero downtime and minimal risk? So for this, we can use the built-in command, which is Terraform state replace hyphen backend. Now this command will perform an automatic copy of your state file from the source to the destination, which in this case will be from your S3 bucket to Terraform HCP backend. Now, how do you validate this? So immediately run the Terraform plan command using the new backend, and the plan must show zero changes to confirm the integrity. And if you see that, that means your migration is completed and there's zero downtime without any impact. The next question we have is, should you use Terraform provisioners like remote exec or a dedicated configuration management tool like Ansible for post-provisioning tasks? Justify your choice. So always the recommendation is to use a dedicated configuration management tool like Ansible for your post provisioning activities. So provisioners lack true idempotency. So basically, if you're using like Terraform, every time you run the code, it will go ahead and make the changes. Unlike your configuration management tool, which follows your make changes once, no matter how many times you run the code. And they tightly couple provisioning with configuration. So configuration management tools separate these concerns and they ensure repeatability, reliable configuration updates. So always, when we talk about your infrastructure management, go with your IAC tools like Terraform. And when we talk about your configuration management, always go with your configuration management tools like Ansible. The next question we have is, explain the use case for a dynamic block in HCL and provide a conceptual example. So a dynamic block is used to dynamically generate repeated nested blocks within a resource based on a complex input like a list of resources or a map of resources. Now, regular count or for each block cannot be used directly on nested blocks. For example, you want to dynamically generate multiple security rules in AWS underscore security underscore group based on the variable list of port ranges. That's where we can make use of your dynamic blocks, because in this case your for each and count cannot be used in your nested block. So basically, whenever you want to repeat your resource creation within a nested blocks, we can make use of your dynamic blocks for that. The next question we have is, for managing dev, staging, and production environments, should you use Terraform workspaces or separate the environments into distinct directories and backends? The recommendation is to use separate directories with separate backends. So you can have one directory for dev, one directory for prod, one directory for staging, and then so on. Now, why this is done? Because this provides you true isolation and dedicated configuration, which is absolutely necessary for your production environments and compliance. Now, workspaces, on the other hand, they share the same code base, but they're only suitable for trivial differences. The next question we have is, when should you explicitly use the depends on meta argument, given that Terraform handles most dependencies implicitly? So the depends on meta argument is used only when there is a hidden or implicit dependency that Terraform cannot automatically infer by attribute reference. So your Terraform handles your dependencies to a large extent, but there are certain situations where Terraform cannot handle the dependencies, and that's where we can make use of your depends on meta argument. Now, the purpose of this is to force a specific order of creation or destruction of your resources, basically your unrelated resources. Like, for example, let's say you want the database to be launched first and then the EC2 instance, or you want the EC2 instance to be destroyed first and then the database. That's where we can make use of your depends on attribute. So example can be, ensuring an external service like a network appliance is fully initialized before another resource is attempting to use it. So basically you want to make sure that one resource is completely ready before another resource can start using it. The next question we have is, why is pinning provider versions important, and how would you handle a scenario where an official provider does not support a niche feature you need? So the reason why pinning versions is very important is because this ensures reproducibility and prevents pipeline failures due to breaking changes that were introduced in a major provider updates. Now, if you need a niche feature, then it is recommended that you create a custom provider written in Go language using Terraform plugin SDK. This allows you to manage any API or any resources under the Terraform framework itself. So if you have a niche feature, then you can create your own custom provider, and always try to pin your provider versions to avoid pipeline failures. The next question we have is, describe a legitimate use case for the combination of the null underscore resource and the local exec provisioner. So use case would be when you want to generate a local configuration files, or you want to execute local scripts based on the infrastructure outputs. Example could be you want to create a local kube config file for a newly provisioned EKS cluster using the cluster's output attributes as input for the local exec command. So the triggers block that you have within your null resource ensures the script reruns only when inputs change. So whenever you want to create something on the local machine, that's when you can make use of your local exec. And null resources, you don't want to create any resources, but you want to take some action based on the resources input. The next question we have is, contrast the use of the count meta argument versus the for each meta argument when dynamically creating resources. So your count meta argument is used when you want to create a list of instances indexed by number like 0, 1, 2, 3, and then so on. And if there are any changes to the middle index, it can cause destructive changes to the unrelated resources. For each, on the other hand, which is a preferred method, creates a map of instances which are keyed by unique strings or map keys. Now, these are safer as changes only affect the specific resources that are associated with the altered key only. The next question we have is, how do you ensure the Terraform state file is securely protected and encrypted both in transit and at rest? So when we talk about at rest encryption, we can make use of your server-side encryption on the remote backend. If you're using S3 buckets, then we can use the SSE KMS. If it is in transit, then we can ensure all the communication between the CLI and the remote backend uses HTTPS, which is your TLS or SSL certificates, which is standard for most of the cloud providers. We can also make use of your access control, so we can enforce IAM least privilege policies to restrict read or write access only to the approved CI/CD roles and approved engineers. And that brings us to the end of our deep dive into advanced Terraform interview questions. If you are able to answer these questions, you are ready for a senior level IAC discussion. This knowledge is your unfair advantage in a competitive market. If you found these questions helpful, please like the video, share and subscribe to the channel for more content. Let me know in the comment sections if you have any queries. Thank you for watching and I will see you in the next session.